My name's Ryan. I am one of the founders of Pyroscope, which is the open source database behind our profiling tool. And yeah, we started it maybe, I guess it's been like 4 years ago now, where we were working at a separate company. We had built kind of an internal system that was doing a hacky version of what Pyroscope now does today. And basically, it was very valuable for our company. We got a lot of use out of it. We saved a lot of money. We saved a lot of resources, and I'll talk a little bit more about that in a little bit. But that basically led me and my co-founder to say, hey, we could probably open source this as a project that other people might want to use similarly and get value to the rest of the community. And so that's what we ended up doing. And today I'm going to talk about not only Profiles Drilldown, which I know you've seen a lot about the various Drilldown suite since you've been here this week, but then also about just why care about continuous profiling at all. It's definitely one of the, I would say, later signals that people tend to pick up, but I definitely think that doesn't mean that it's just as valuable, if not more, than some of the other ones that you might be more familiar with. Yeah, you know the drill, Q&A. Yeah, so here's the why care about continuous profiling? I like to always start with this because there's a lot of people out there who say various schools of thought about various observability tooling. You know, you only need traces, you only need logs, you only need metrics, whatever it is. And the way that I kind of see it, especially coming from somewhere where we had started with profiling just totally on its own, is that, you know, if you have a hammer, everything looks like a nail. It's very easy to, as a profiling database, to say, oh, everything's a profiling problem, or, you know, regardless of which database it is. But as it turns out, you know, really having this whole suite of tools means that you end up getting the best tool for whatever task you're trying to do, which sometimes is profiling, sometimes it's traces, logs, metrics, load tests, whatever that might be. And so really being able to use all of these tools together is something that makes them all more valuable collectively, and that's what we've really focused on inside of Grafana, is kind of expanding past just providing profiling in a silo with Pyroscope, but also connecting to other tools like Tempo, for example. Cool. And this is kind of just showing, I would say this is something that is a very unscientific visualization of like sort of how things progress. And so, you know, normally you start with a signal, you start with it locally. You know, for example, like most of us, the first thing we ever typed was hello world on some language somewhere. And then, you know, you move into a little bit more official where it's ephemeral, it's on machines. You move more official than that, where you start to centralize it with some sort of database, whether that's, you know, S3, ClickHouse, you know, any of the databases that, you know, we have here, whatever that might be. And then you kind of move into more kind of production data somewhere that all that data kind of talks to each other. And so, you know, everything sort of moves to the right, you know, whether it kind of skips one or jumps over the other. But the big thing that I want to talk about is just how profiling is really sort of experiencing this shift right now, where I would imagine a lot of people in here and a lot of people who I've talked to at the booth and throughout this week have said, you know, hey, I'm doing some sort of profiling, I have this data, you know, we store it in S3 for my company, or, you know, I pull it down, I just have, you know, a little file, pprof file on my desktop, whatever it might be. And really we're seeing a much more rapid shift, I think, with profiling from that level of profiling to a more continuous sense where you can have something that goes wrong in production and you don't have to try to recreate it to get a profile associated with that. Instead, you just query the Pyroscope database and you can pull profiles of what's going on from a performance standpoint from your application, pull Flamegraphs. And like I said, I'll show some examples of, if you aren't familiar with profiling and what a profile is, what a Flamegraph is, I'll show that in a little bit. One of the big reasons that I think it has made this big jump has been a lot of the work we've been doing with OpenTelemetry. And so several years ago now, I guess 3 years ago now, in April of 2022 at KubeCon, profiling was voted the #1 like requested new signal that people wanted to see in OpenTelemetry. And so basically, we took that information. This was before we had joined the Grafana suite of tooling. And we were basically like, okay, well, this seems like something people want. We obviously are very knowledgeable about profiling, and so we decided to start the group that would eventually get it into OpenTelemetry. At that time, we were very, bright-eyed, bushy-tailed, and we were like, oh, maybe 6 months, and we'll have it, into OpenTelemetry. If you know anything about OpenTelemetry, nothing happens in 6 months. So, many things have happened since then. And honestly, I think it was for the best because we've really, really kind of nailed down the best format for the data, the best way of sending the data across the wire, the best way of connecting the data to traces or logs or other signals. And so we've done that over these past several years. We've met with several language maintainers, Go, Java, .NET, and gotten a lot of feedback and just made sure that the direction we're going is one that will last very far into the future and not be just yet another format for profiling data. And so, here we are in 2025, about 3 years later, and I would say that my estimate would be in 6 months again, but this time I actually, believe it much more than I did then, based off of the progress that we've made, and it's in experimental right now, so you can actually use the OpenTelemetry profiler to collect profiles. We just need to basically graduate from experimental to stable, and so all that work is ongoing right now. And the other reason that I think profiling is really unique compared to the other signals is that it's the only tool that really directly optimizes both sides of the ROI equation. And I know that's something that definitely can be a hot topic when it comes to observability data. How much are you collecting versus how much value are you getting back from that data? And the interesting thing about profiling, and I'm going to show some examples here in a second, is that on one side you can definitely increase the revenues that you're getting from your application because you're able to increase throughput, you're able to just have a better user experience with your applications running faster, reduce latency, and all of those are directly tied to the information you get about your application in the Flamegraphs. And then on the other side, you have the cost side. This is one that I think is much more unique to profiling, where you're able to basically see where your costs are going, whether that's memory, CPU are the most popular ones, but really any resource, you can get info into how much it's costing, so that you can then optimize those costs, minimize those costs. And a lot of times, as we've seen with many people using this, it tends to be some easy, low-hanging fruits of things that you didn't realize were using as much resources as they are. All right, and so and kind of similarly as the kind of to the ROI conversation, there's also sort of a proactive approach to using profiling, and then a reactive approach to using it as well. This is also something that I think is pretty unique to profiling, in that with metrics, logs, traces, a lot of times you're going to get most of your value from those when you're something's on fire. You're able to get an alert, and you kind of go down the path of investigating it. With profiling, you kind of have this nice sort of proactive approach that pretty much any time you turn it on, unless your application is perfectly optimized, which is just not really a thing, and so in reality, as soon as you turn on profiling, you're going to understand something that if you're not using profiling, you just don't know, like, what is the biggest bottleneck in your application? When traffic spikes, what's the first thing that's going to fall over, that's going to cause CPU to run out, that's going to cause memory to run out, whatever that might be? And you can discover all that proactively with profiling, and then have that benefit. And then on the opposite side, when something does happen, now you already are familiar with it, so that you're able to react to an incident or a latency issue or a customer request or whatever that might be, and use profiling as as needed there. Here's a kind of an example sort of showing what that looks like. So a big thing that people often think about with profiling, I would say the #1 question that we get when people try to start using Pyroscope for the first time is, what's the overhead, and how much is it going to cost me? And it's a valid question, but what we usually say and what is true about it is that it is very low overhead because we're using sampling profilers. So, if you've used profiling in the past and you've had problems with overhead or how much overhead it's adding to your application, that's likely because you were probably using a different kind of profiler. Whereas this one is just simply like sampling the stack trace 100 times per second to be able to understand what's going on in your application, and then it's sending that off to whatever backend. And the convenient thing there is that it's happening from a separate process. And so if you think about that relative to your metrics, logs, traces, other signals that you're doing, in those it's typically going to be some sort of code that you've inserted into the path of your application. And so just by default, that's more likely to actually have much more overhead for your application than profiling ever would. And so one of the most popular things that we end up finding once people add profiling for the first time and start using Pyroscope is that they realize, oh, we were accidentally spending 10% of CPU logging some useless thing that we weren't supposed to be logging, or we were had too many trace spans and those were causing too much issues, or whatever that might be. And so that's kind of where having this observability into what your application is actually spending its resources on is almost all, or I mean, yeah, I guess I'm biased, but I would say always worth the the 1% overhead to understand what's going on with the other 99% of your resources that you're spending. And I talked about the observability side. That's just the top one here, but that's true for your incidents. That's true for messaging and queuing systems. Is actually I would say one of the most popular ones. So if you ever have overflowing queues, Kafka consumers, Sidekick workers, whatever your queuing system is, profiling is always a very, very good tool because it's notoriously an area where you can kind of just send something to your asynchronous land and just forget about it, and then it's really common that it then picks up a lot of bloat and can then cause problems later, and profiling will help you fix that. And then obviously infrastructure, deployment tools, other things as well. A couple examples of this. One of our biggest profiling users, Shopify, this was a tweet from their CEO talking about how much traffic they deal with on Black Friday. They're kind of like storefronts, I guess, for lack of a better way to describe it. But yeah, basically they're doing tons of requests, and for them, they're processing so much money through their platform that 1 minute of downtime can mean almost $3 million in lost revenue. And so they started using profiling in this kind of preparation scenario in order to be able to either get zero downtime, or whatever downtime is there, resolve it as fast as possible. And so they actually had some really cool examples that they found using Pyroscope and profiling to. They made some improvements to various Rails libraries and system libraries and things like that they were able to then decrease their CPU by over 20%, which at that scale is a massive amount that they're then saving on their infrastructure. And so my favorite is a quote down here from one of their engineering directors about how one of their engineers who was focused on efficiency and performance was like, I had no idea how I was doing this before continuous profiling. And so if you're someone who, it's your job to be focusing on performance, this is going to be something that's, super helpful for you to have and be able to just have a good idea of what's going on in your application. Another example, this one I like to share for slightly different reasons. They were focused more on the cost side. People here I think are very familiar with Uber, and basically they were able to use profiling to decrease the amount of cores that they had, and they deployed it across their entire infrastructure and were able to cut out over 10,000 cores, saving a lot of money in their on their infrastructure. So yeah. And so what allows this to happen, I'm going to kind of quickly go through a little bit of why the database works so well. So two things about actually both of those companies I just mentioned, and possibly some of you here, many other companies that we talk to, is that you kind of have built some sort of system. Maybe you're just dropping these profiles into object storage, And so this is how a profile gets turned into a flame graph. And so basically what you're seeing here, these are just like, simple functions with how long they're being run, and then they turn into a flame graph like this. And so, more than just, dropping them raw into S3, which would be very cost prohibitive if you were doing that as essentially using that as a database or whatever your object storage is that we then do a lot of compression to make sure that all of this data that is getting replicated, duplicated many, many times as you're adding these flame graphs to your wherever you're storing them, we then use trees to compress them very, very heavily. And then after we compress the actual functions themselves, the symbol names themselves as well tend to have a lot of duplication. So here you have net/HTTP request, net/IO read, net/IO write. You don't need to save net that many times in the database. And so by also serializing those symbols, we're able to then get the actual storage of the profiling data down very, very low. On top of that, then it's like, okay, so you have all this profiling data. Again, we're collecting it continuously. And so, let's say you're getting a profile from every pod, every 10 seconds. And so that can really add up very quickly. Now, if you want to get a profile of the last week's worth of data, you then need to, somehow at read time or at query time, merge all of these profiles together so that you get, one profile for the last week or the last month or whatever. And so basically how we solve that problem is we use these segment trees. Storage is cheaper than compute. And so essentially we store the profiling data at different levels to make it so that, if you're then querying 50 seconds worth of profiling data, it goes from you, getting all these segments to, instead of doing 4 merges, you then just do 1, merge of a giant segment and a small segment in order to, get those queries. I'll save this for after and go ahead and switch to the demo. And show you a little bit about what the Drilldown app looks like and how you then would, solve an issue inside of a UI. So for this, we're going to use a sample rideshare application just because that's what people, more for conceptually so that you understand what's going on here. And so basically, we have a region label, we have a vehicle label, and I'm going to show you how this looks when we're collecting profiles from these various regions and then viewing them inside the UI. And so if I go to the Drilldown app here, yes, I think it's definitely big enough. And so the Drilldown app here, and so basically what we've built is something that allows you to drill down into the root cause of an issue. And so if you start at the high level, you have all of the services here. In this case, we have our rideshare service, some other services. We're looking at the CPU for this service and seeing if there's anything interesting here. Maybe there's CPU spiking, like there is here. I'm not going to go into that one for this demo, but yeah, that allows you to kind of see from a high level what's going on there. And so from there, you can drill down either into the profile types or the labels for that service. So I'll start with profile types. So now we're looking at the same service here, but we're looking at all the different profile types for that service. I'll switch to grid here so you can see them all. CPU, allocated objects, allocated space, in-use objects, in-use space, and again, now this allows you to see a little bit more information about something you might want to dig more into. We can click into our labels here, and so, well, actually, I'll do Flamegraph first. So, from there, you can go into the Flamegraph, and then now you're just looking at over the last 30 minutes, these are all the data points that we have. They've all been aggregated together to say that we spent 23 minutes of CPU time, and these are the functions that we spent that CPU time on. And so, you can see here what the bottleneck would be, and if you can start there. But we also have these labels here. And so, like I said, I showed before that there was the region label, there was the vehicle label, and you can see that reflected here. We also have span name here, and so we're actually connecting these profiles with our traces to be able to actually get a profile per trace span as well. So yeah, so now from here, you can already see, if I go to totals, for example, you can see that the north region is using 4 times as much CPU as these other 2 regions. I could also go to maximum, I can go to histograms, but based off of these totals, like let's say there's an incident going on in the north region and we need to resolve it. Now, if you just had metrics, you might see something like this that's showing that this region is using a ton of CPU. But if you actually have profiles, you don't know that this is just using the CPU. You can know the functions that are associated with it. So if I select this as my baseline, and I select this north region as my comparison, and I hit this compare button, I'm going to just auto-select a time period. Now what we're seeing is that there is the difference. It's almost like a git diff. The difference between the south region and the north region is that we only spent 28% of CPU on this specific function in the south region, and then in the north region we used 78% of CPU on the same function. And so, if there was an incident, like now this is telling you specifically why you're running out of CPU, as opposed to just showing you that you're using a lot of CPU. And so, now you know down to the line of code. There's some nice bells and whistles here as well. We have this LLM integration here that allows you to also kind of explain this. There's a lot going on here, obviously, especially if you're not familiar with Flamegraphs, but this actually will kind of walk you through what the impact is, what the biggest problems are in the application, and what you should look at to go fix it. And so this kind of shows you that. And then if we actually go to the Flamegraph here, for now we only have this for Go at the moment, but we're actually bringing this to other languages as well. Because we're so close to the actual code here, I can go to function details, and I can actually connect this with GitHub, and it will bring up this actual function that we're running and what's actually happening here. And so in this case, this is a demo, so you can actually see how I got the demo to look like this. I basically just said, if the region is EU North, force a mutex lock, and then it's forcing a mutex lock. And so that's how we're able to see that there. But yeah, and so then this allows you to see that. The last thing I'll show is what this looks like inside of our traces there. See demo traces. So I'm gonna select that same service, rideshare go, and run a query. And so here I can sort by like the slowest traces. And so here we can actually see that there was one trace that was significantly slower than the rest. And so similarly to how we were looking at all those profiles that were aggregated together, here we're looking at one profile that is associated with with just this specific trace span. So this trace span was 19.2 seconds. We see this profile was 19 seconds, and so now you know more than you would just have with just tracing, but you have a little bit more insight here into what's actually causing that slowdown. We can switch back to the slides, I think. Yeah, and so that's kind of a real quick intro to the to how our Profiles Drilldown app works. And yeah, if there's any questions, I can answer those now.